Hello, classmates! When there are multiple power supplies in the circuit, conventional circuit analysis method become complicated. In view of this situation, next we will learn a new analytical method, superposition theorem, which cleverly simplifies complex problems. Superposition theorem is a fundamental theorem about linear circuits. It embodies a basic property of linear circuits, superposition. The content of superposition theorem is that in a linear circuit with multiple power supplies, the voltage or current of each branch circuit is equal to the algebraic sum of the generated voltage or current when each power supply acts alone. In other words, it involves adding up the effects of each power supply individually. The so-called independent action of power supply refers to the action of a particular power supply in the circuit, while the other power supplies do not operate. If the voltage source does not operate, it is equivalent to a short circuit. If the current source does not operate, it is equivalent to an open circuit. Applying the superposition theorem enables us to divide a complex circuit into several simple circuits for study. Then, by combining the results of these simple circuit calculations, we can obtain the current and voltage in the original complex circuit. When calculating power, the superposition principle cannot be applied. In the circuit shown in the figure, the left picture shows the original circuit. The middle picture shows the U sub S1 alone acting circuit, and the picture on the right shows the U sub S2 alone acting circuit. The basic structure of the three circuits is similar. When analyzing the circuit, the parameters of the circuit should maintain the same names and directions. When U sub S1 acts alone in the middle picture, with the voltage source U sub S2 as a short circuit, and the original position replaced by a wire, we can analyze it by conventional methods. At this time, the currents are I1 times, I2 times, and I3 times. On the right, when US2 acts alone, with the voltage source US1 as a short circuit, and the original position replaced by a wire, we can use the conventional method to analyze the currents at this time, which are I1 times, I2 times, and I3 times. By combining the analysis of the two, we can infer that in the original circuit, I1 equals I1 times plus I1 times, I2 equals I2 times plus I2 times, and I3 equals I3 times plus I3 times. For example, using superposition principle, find I2 in the circuit shown in the figure below. We can analyze the circuit using the superposition theorem. When the 12V power supply acts alone, we substitute the values into the calculation and obtain I2 times equals 1A. When the 7.2V power supply acts alone, after analysis, we substitute the values into the calculation to obtain I2 times equals negative 1A. According to the superposition principle, we can obtain that I2 equals I2 prime plus I2 equals 1 plus negative 1 equals 0. For example, using the superposition principle, find I in the circuit shown in the figure below. First of all, there is a voltage source in the circuit diagram, and there is also a current source. When analyzing the isolated impact of a power source, it is essential to apply the superposition theorem. Using this technique, we can analyze the impact of the 4A current source in isolation. After substituting the relevant data into our calculations, we can determine that I times equals 2A. When the 20V voltage source acts alone and the left branch is disconnected, substituting data into the calculation gives I times equals negative 1A. According to the superposition principle, I equals I times plus I times equals 2 plus negative 1 equals 1a. Through a few examples, let's sum up. Matters needing attention in the superposition theorem. 1. The superposition theorem only applies to linear circuits. Circuit parameters do not change with the change of voltage and current. 2. When superimposing, only consider the power supply separately. The structure and parameters of the circuit remain unchanged. The constant voltage source is temporarily ignored, which should be short circuit, even if E equals 0. The constant current source is temporarily ignored, which should be an open circuit. That is, IS equals 0. 3. When solving problems, it is important to indicate the positive direction of current and voltage in each branch, the voltage across each component in the original circuit, the ultimate result of the current, and the algebraic sum of the individual voltages and currents across different branches. To sum up, we know that the superposition theorem can only be used for calculation of voltage or current, cannot be used to calculate power. That is, power cannot be superimposed. When applying the superposition theorem, the power supply can also be solved in groups. The number of power supplies in each branch circuit may be more than one. As for more knowledge, see you next time.